Okay, this is the sample that I took the other day out of the Jordan River. We can look down there and see that it has settled a little bit, sediment in the bottom. I'm now going to go ahead and take a reading with the TDS meter, and you can see that it reads all zeros. Let's see what this does now that we have this sample at room temperature. Oh, wow. This thing is nearly maxed out. On this particular meter, I cannot get a reading in excess of 999. There it goes to air. So it's even exceeding the meter's ability to read the sample. So you can see that this is a very polluted sample of water. I'm not content just with that. What I'm going to do is I'm going to add a container of salt to this, and it will do one thing and one thing only. It'll significantly add to the pollution that we are going to have to clean up before this water becomes potable in any way, shape, or form. So here we go. We're going to pour this salt into this polluted water that we know already is over 980 parts per million. And what it actually is, I'm not exactly sure, but it's a very high pollution reading that we've got in here. The salt, of course, can be utilized to simulate ocean water. Ocean water, by the way, is some of the most polluted water on the planet, typically coming in at reads on total dissolved solids of over 30,000 parts per million. So what I'm going to do now is stir this up real good, and then I'm going to set up the distiller, and we're going to purify this awful water so that it will then be totally fit for human consumption. And of course, once I get a distilling out of this, we're going to measure it again with the TDS meter and see just how pure the concept of steam distillation will make this totally unsuitable water.